Good day, everyone, and welcome to this EFF-CoP podcast that is part of the European project focused on strengthening collaboration between research and industry in the field of food fraud prevention and detection. EFF-CoP stands for European Food Fraud Community of Practice, and its goal is to bring together researchers, industry professionals, and stakeholders to exchange knowledge, share tools, and explore innovative solutions for food integrity challenges. Food fraud is becoming increasingly complex due to the global supply chains, our evolving market pressures, and also the growing demands for transparency and sustainability. And at this time, new technologies and innovations, especially artificial intelligence, are opening up powerful opportunities for detection, prevention, and risk assessment. In today's episode, we will explore how AI is helping to detect and prevent food fraud, what this looks like in practice, and what challenges still remain.
Thank you, Sara, for the introduction. Hello, everyone, and welcome also from my side. I'm Anastasia Vlachou from Erasmus, and I will be co-moderating today's discussion together with Sara Erasmus from Wageningen University. In this episode, we are joined by two experts working at the intersection of food fraud prevention and artificial intelligence. From Wageningen University, we have Dr. Yamine Bouzembrak, whose research focuses on AI and data-driven approaches in food safety and food fraud detection. And from Erasmus, we have Dimitrios Tsolis, an external collaborator and assistant professor at the University of Patras. He brings valuable experience in supply chains, quality assurance, and practical challenges in food authenticity with a background in electrical and computer engineering. Thank you both for joining us today.
Thank you so much.
Thank you very much. Thank you.
So I think we can start with the questions. I'm going to start with you, Yamine. Could you briefly tell us about your work and how AI connects to food fraud research?
Thank you so much for the question, and my pleasure being with you here, guys, and answering your question. I'm associate professor here in Wageningen University working on how AI can help solve challenges in food and health generally. And one dimension of my research is basically food fraud research. What we do there, we use AI to analyze large and diverse data sets to detect risks, uncover weak points in the food supply chains, and support product authentication. More recently, even we have been also exploring how large language model can help different actors across the food chain detect and prevent fraud more efficiently.
Thank you very much. Dimitrios, from an industry perspective, how do you encounter food fraud challenges in practice?
Yes, thank you very much, Natasha. From an industry perspective, food fraud is not always visible at first sight. It often appears as a hidden risk inside complex supply chains. So companies may work with many suppliers, raw materials, intermediaries, transporters, etc. So at each stage there can be vulnerabilities and risks regarding food fraud. In practice, the challenge is that food fraud is both a technical and a business issue. On one hand, we need reliable analytical methods and quality controls. On the other hand, we need good technologies, tools, so as to enhance traceability, documentation, and risk assessment. From companies, the key question is not only if we can detect fraud after it happens, but also if we can identify where the risk is higher before it becomes a real problem. This is where data, digital tools, and AI could assist. We will see this later on. Thank you.
Thank you.
I would like to move on to the next topic, which is looking at AI in food fraud. And specifically, I would like to ask you how AI is currently being used to detect or prevent food fraud.
Very good question, Sarah, and thanks for asking it. Basically, it's a tough one as well, but luckily based on our literature review published the beginning of this year, I can update you on what is the current state on that. AI is increasingly used in food fraud detection through machine learning and deep learning models that different kinds of data sets such as spectroscopy, sensor data, and lab results are combined. These systems help identify unusual patterns linked to adulteration, mislabeling, and authenticity issues in products like spices, oils, meat, honey, and dairy products. For example, when combined with spectroscopy or imaging, AI can help detect cases such as diluted olive oil, adulterated spices, and mislabeled meat. Methods like SVM, which is support vector machine or convolutional neural network, are often used because they can capture complex chemical and visual patterns that are different from humans, that are difficult for humans to see. Beyond detection, AI is also moving forward prevention, where predictive models can use historical fraud cases and supply chain data to assess risk before issues occur. New approaches like federated learning also, in the sense allow organizations to collaborate on fraud detection without sharing sensitive data, which is a big issue when it comes to prediction of food fraud in the food chain. At the same time, the explainability dimension as well is becoming important to ensure transparency, so experts and actors in the chain can understand why a product or a step in the food chain is flagged as high risk, for instance. That's in short, basically.
Thank you so much, Yamine, for your answer. And I would like to follow up this to Dimitrios by asking if you see these AI tools being applied in real industry settings already.
Yes, thank you, Sara. Yes, of course, we are still in a transition phase, but I have seen in the industry, there are AI tools that are being used in areas such as anomaly detection, all the areas that Yamine has already mentioned, supply risk assessment, for example, pattern recognition and analytics in large data sets. For example, AI is helping now to identify unusual price changes in certain cases or suspicious supply chain patterns and inconsistencies. In Rezos, for example, like a practical example, that we are an SME, like in many companies, we are using AI not in a limited way. Let's say that we are gathering data in our supply and the supply of the food chain, the food supply chain, and this data is being stored in databases or repositories or blockchains. But we can apply AI to this data, but not holistically in the food supply chain still. So in areas that we are gathering big data, we can do AI so as to optimize our different methodologies and processes, but we cannot still do this in all the food supply chain. So I think that the potential seems to be very strong. The successful implementation requires more than just buying an AI tool. It requires good data holistically in the food supply chain. And now we are in this transition, I think. From our experience and practical expertise, for example, we are gathering data in the field from sensors, and we can apply AI tools in this data so as to optimize the processes, the agricultural processes, and optimize the goods and the quality of the product. But we cannot do this in the holistic supply chain, which will be the next level. Thank you.
Thank you, Dimitrios, and thank you both for showing us what the level currently is within theoretically, so literature, but also in real life settings, industry settings. And Dimitrios, you mentioned that data is a core component, and therefore I'd like to ask Yamine, what kind of data would then be needed for AI to work effectively in this field?
Yes, AI depends on data strongly, and it is both in a dual way, both the opportunity and the barrier. So in food supply chains, the data may be incomplete, fragmented, or not standardized. So different companies use different systems, different terminologies, different levels of digital maturity in each company. This makes it difficult to build AI models that are reliable and transferable to all the industry. So this is a barrier here that has been identified. Second barrier is mainly trust. Companies need to understand how an AI system reaches a conclusion the explainability of the AI, which is something that the EU is strongly supporting, and the guidelines from EU state clearly that all the AI tools that are being used by Horizon and European projects should be based on explainable AI, which is an AI component with which you can trace back to the data used and the algorithms used so as to produce the conclusion and the AI conclusion and the decision support. So trust is a very challenging concept from companies. If you can persuade the company that you use explainability in your AI so as to trace back the root of the decision, then you can produce trust and alleviate this barrier. A third barrier is cost. So a company will ask, okay, which will be the investment, and if the investment will be actually returned. So this is something that is depending on the case. Do I need AI specialists, advanced digital infrastructure? So we need solutions that are practical, explainable, and accessible, especially for SMEs, and to persuade the SMEs and the companies that are in the food industry that AI is not so complicated as it seems, and that there are already solutions that we can depend on so as to give AI tools to certain stages of a food supply chain.
Yamine, do you want to comment on that?
Yeah, I fully agree with Dimitrios. He covered all the question basically elegantly. I will just add some dimensions on it basically. In short, if you ask me the question, I would just say AI systems rely on high quality. The quality is very important, the quality of the data. As big as possible. All AI models are data hungry, and representativity as well. It should be representative data that reflect the real world, what's happening in the world really, not lab-based, which is the most what we find in literature now. If you ask what we are doing now in literature, basically you will find most common source of data is spectroscopic data, which captures the molecular composition, followed by imaging data such as RGB and hyperspectral images that reveal both visible and hidden structure features. In addition, you will find as well some AI models developed using electronic sensing systems like e-tongue, e-noses, provide chemical information related to the aroma, volatile compounds, and taste profiles, for instance. Combining this data, the most current approaches are supervised learning, which depends on labeling. Basically, you need the ground truth to build such kind of models. Then these data sets are typically created in controlled laboratory settings, which is a big limitation to help models learn to distinguish between what is authentic, not authentic, what is risky, not risky, for instance. That's in short what is in literature.
Thank you. Dimitrios, from your experience, do you think companies trust AI-based systems?
I think not yet. Surely they seem to be very interested in AI because AI is a tsunami now which horizontally affects many sectors of human creativity and activity. But trust, especially in companies, is built gradually. So in food businesses, decisions are often linked to safety, quality, reputation, legal responsibility. So companies cannot rely blindly on a system that do not understand. They need evidence that the AI tool is accurate, reliable, and useful in real operating conditions. So I think that companies are more likely to trust AI when it supports human decision making, basically, rather than that replacing the human decision making. So, for example, if AI highlights a suspicious pattern, a quality manager can investigate further based in his or her experience. In that sense, AI becomes an early warning tool or a decision support tool. In this way, I think that companies will gradually and eventually trust AI. Also, trust increases when the system is transparent. It seems transparent to the final user. So users need clear explanations, the explainable AI that I have told in the previous remark, not only to have a decision, but to have the explanation of how this decision has been produced by an AI tool. So yes, company can trust AI-based systems, but this trust required validation, transparency, training, and time. Thank you.
Thank you, Dimitrios. And Yamine, where do you see AI in food fraud prevention in, say, the next 5 to 10 years?
Wow, that's a difficult question. So I don't have a crystal ball, but I can give you, let's say, some what are we doing these 5 years at least? It might be even change for us as well. So let's say, as mentioned by Dimitrios in the sense, rather than focusing mainly on detecting fraud after it happens, future systems, we think, will emphasize an early risk prediction by combining data from supply chains, trade flows, all kinds of data that we can gather in the food supply chain, sensing, imaging, or satellite images, whatever is in there, to identify vulnerabilities before products are compromised. Basically, everything before it happens, we become more proactive in that sense. We will also see more multi-model AI, integrating again more technologies, enabling like foundation model and LLMs, integrating spectral, imaging, chemical, logistical, all kinds of data to build really more robust food fraud. You can play different scenarios. You can be more proactive in predicting. At the same time, the field is likely to shift from detecting known fraud patterns to more general anomaly detection, that helping allowing system to flag previously unseen types of fraud as well, saying, hey guys, the expert, there is something here. We don't know like a system, what is it exactly? It's just I am flagging for you, really, please do something about it. Another important direction that we are exploring is the integration of AI with technologies such as IoT, blockchain, improving traceability and enabling more transparent real-time monitoring across the food chain. Portable and handheld sensors may also move food fraud detection closer to the point of production or inspection in that sense. To support these advances, there will be strong need for larger, more open data sets, potentially supported by citizen science and decentralized data collection to overcome the current data limitation. It's a big limitation. If I look at the most recent literature review we did, only 3% of the data was accessible. All the data in the food fraud research, can you imagine, only 3% of that data was open access, which was really small and limited. Overall, AI is expected to evolve from lab-based, which is more controlled environment, reactive tools, into proactive and collaborative ecosystem that strengthen food integrity across the entire supply chain.
Thank you, Yamine, for that really good view on the crystal ball for the next 5 years. And then I'd like to go to Dimitrios to ask, what should companies now start doing to prepare for that future?
Okay, from my point of view, I think that companies should start by improving their data culture. So they have the first step is not necessarily to apply new and advanced technology, but is to implement a good digital transformation project. If they do this and then identify areas that they are most vulnerable, relevance with the food fraud aspect, then an AI tool could act and an assistant, a very strong assistant, so as to have the anomaly detection and early warning components that are very useful for food fraud detection. And to do this, you don't need only technology, you need people. So you will have to invest in quality assurance teams, training for the basics of AI and data interpretation and manipulation, risk-based thinking for the personnel, to invent to people. So, and finally, of course, companies should collaborate. Food fraud cannot be solved by one company alone. This is true. It requires cooperation between industry, researchers, authorities, technology providers, and initiatives such as communities of practice, like the one that the EFF-CoP is now implementing. So it's very critical to collaborate and interoperate so as to share knowledge, improve tools, and build more resilient food systems in this sense.
Thank you. So, as a final question, in one sentence, what is the most important takeaway for our listeners? Yamine, do you want to answer first?
Okay, in short, let's say with AI, food fraud prevention becomes, let's say, earlier, smarter, and more open.
Thank you. Dimitrios, what about you?
Yes, AI will not replace human judgment in food fraud prevention. It will strengthen it. It will help companies to detect risks earlier, act faster, and make better informed decisions.
Thank you very much. Thank you both for this very insightful discussion, and thank you to our listeners for tuning in to this EFF-CoP podcast. Stay connected for more conversations on food integrity, innovation, and collaboration.
Okay. And from my side, I'd also like to thank you both for this very insightful discussion, and that we should not be afraid of AI, but embrace it. And then for those listening, that would like to learn more about this project and our related activities, you can find additional information through the official EFF-CoP project channels and website. And also thank you for listening, and we hope you'll join us for the next episode.
Thanks for having me. It was my pleasure.
Thank you very much.
Thank you.